The next topic that we are going to talk about is on sequences and series. Our discussion on sequences will be shorter, but our discussion on series will be longer. In this lesson, we talk about sequences. So we talk about sequences. So as you know from more elementary courses, a sequence is an ordered list of numbers. So, as an informal definition that you might have seen in more elementary courses, an infinite sequence is an infinite ordered list of numbers. And by the way, the repetition is allowed. You can repeat a number. So let me mention this in the parentheses, repetition is allowed. So, for example, the set of or the sequence of positive even integers is a sequence. In fact, any list of numbers, I mean, an infinite list of numbers, which is given in an order, will be a sequence like 2 minus 1 minus 4 minus 7. As I mentioned, we can repeat a number in the sequence. For instance, 1, 2, 1, 2, 1, 2, and so on and so forth. So repetition is allowed. Or the sequence of 0, 1, 0, 1, 0, 1, and so on and so forth. As you might have seen in more elementary courses, sometimes we give the general term of a sequence. So the notation that you might be familiar with is that the general term is given by, we use a letter and with some index, for instance, AN. Or we might use a pair of braces like this, AN. Sometimes we mention that n runs from where to where, like n runs from 1 to infinity, but we are aware that n is an integer. So either of these two tells us that the sequence consists of, so if n runs from 1, the first term is A1, second term A2, third term A3, and so on and so forth. Let me write a simple example, similar to what you have seen in more elementary courses. Let A and B n over n plus 3, and this is for n's more than or equal to 1. As I mentioned, when we talk about sequences, that index is an integer. So this means that n runs from 1 up to infinity. Uh, as just a reminder, let's do this question. List the first four terms of this sequence. In other words, I want to list A1, A2, A3, and A4. So what is A1? A1 means in that formula on the top, An is n over n plus 3, n is 1. So that's going to be 1 over 1 plus 3, 4. A2 means n in the formula of n over n plus 3, n is 2. So 2 over 5. When n is 3, 3 over 3 plus 3, 3 over 6 can be simplified as 1 half. When n is 4, we have 4 over 4 plus 3, 7. And so on and so forth. One important thing that is of interest in calculus is when we have a sequence, does the sequence converge to a specific finite number or not? For example, when I have this sequence, let the general term be n over n plus 1. And n runs from 1 through infinity. So when n is 1, so a1, when n is 1 is 1 over 1 plus 1, 1 over 2. When n is 2, it is 2 over 2 plus 1, 3. When n is 3, 3 over 3 plus 1, 4, 3 over 4. When n is 4, I have 4 over 5, and so on and so forth. The question is, are these numbers converging a specific finite number? To have a more clear idea of that, let's write the decimal values. 1 half is 0.5. 2/3 is rounded to two decimal places is 0.67. 3/4 is exactly 0.75. 4/5 is exactly 0.8. So we see that as n becomes bigger and bigger, these numbers are growing. Of course, they cannot exceed 1 because n over n plus 1, n is always less than n plus 1. N is always less than n plus 1, so that fraction, it cannot pass 1. But as we can try bigger n's and see what values the fractions will realize. And it turns out n over n plus 1, the limit is 1. So the limit of n over n plus 1 as n tends to infinity equals 1. So If this happens, I mean, if something like this happens, that for a sequence, the limit is a finite number, in this case, that finite number is one, the sequence is convergent. Of course, soon we'll talk about a theorem that we find the limit of many sequences using calculus, using the limit discussion of calculus, as you have seen the limit discussion in Calc 1. We use those kind of things to find the limit of sequences. So let's talk about that theorem that I just mentioned, that we use the limit discussion of calculus to find the limit of some sequences, not all sequences, some sequences. So let's A n be a sequence. Let me use this notation. Let A n be a sequence. I want to relate that to some function, some continuous function. Let f of x be a continuous function over the closed interval from 1 to infinity, such that at every n, the value of f equals an. So f of 1 is a1, f of 2 is a2, f of 3 is a3, so on and so forth. But f is also defined at numbers other than integers. In addition to integers, it's also defined on other numbers from 1 up to infinity, and that f is continuous. So this is the assumption of this theorem. If the limit of this f, the limits of f of x as x tends to infinity equals L, then the limit of that sequence is also n, is also L. So if the function has a limit of L, then we can conclude the sequence has the limit of L as well. So let's apply this theorem to some examples to see that how it works. So suppose the sequence is this sequence. Let an be 2n plus 1 over 5n minus 3, and n for n is more than or equal to 1. So this is our sequence. I can give the values of 1, 2, 3, 4, and so on and so forth to find the values of the terms of this sequence. And now I ask this question, which one is correct? A, the sequence converges to a finite number, and I want to write that finite number here. Or the sequence does not tend to a finite number, and the sequence diverges. But before doing this example, remember that converges means that the limit of the sequence is a finite number. So if the limit of the sequence, let me write that on the reminder or as a note. If the limit of a sequence is a finite real number, the sequence is convergent. Otherwise, it's divergent. Okay, now how do we deal with this? Using the theorem that I just talked about. What continuous function from 1 to infinity can you relate to this sequence? That's quite simple. For this example, f of x in the sequence 2n plus 1 over 5n minus 3, just replace all the n's by x. So I get 2x plus 1 over 5x minus 3. This is the continuous function over the interval from 1 to infinity. And at every n, f of n will be an. That's obvious. Now we can use calculus 1 type questions to find the limit of f of x. The limit of f of x as x tends to infinity, or in fact, the limits of 2x plus 1 over 5x minus 3 as x tends to infinity. As you might remember from Calc 1, when you have a rational function, a polynomial over a polynomial, and x tends to plus infinity or minus infinity, we can keep the leading term of each of these two polynomials. So when x tends to infinity, from the top, I can just keep 2x. That's the term with the highest power on the top. And from the bottom, I keep 5x. I hope you remember this from Calc 1 when you discuss the limits. Now here it's easy. X and x cancel out, and the result is 2/5. You could have obtained the same result by using L'Hopital's rule. So I got a finite number. According to this note, if the limit of a sequence is a finite real number, the sequence is convergent. So here the sequence converges to, I should type in 2/5. Let's do another example. Please try this on your own. Suppose the sequence is given with the general term of an is 4n cubed minus 6n squared plus 2n plus 10 over 5n squared plus 7n minus 1, and n runs from 1 through infinity, and n is an integer. Now this sequence, so which one is correct? A, it converges to this finite value, or it diverges. What is the continuous function that you will consider for this question? Obviously, it's simple in this case. Just replace all the n's by x's. So 4x cubed minus 6x squared plus 2x plus 10. This is not a sequence anymore. It's a continuous function. And at the bottom, 5x squared plus 7x minus 1. On the top, it was a sequence. Here, this f of x is a continuous function. Now, what is the limit of this continuous function as x tends to infinity? We can use calculus 1 information and find this. As x tends to infinity, since I'm dealing with a rational function, I can keep the leading term, the term with the highest power, on the top and at the bottom. On the top, I keep for x cubed. From the bottom, I keep 5x squared. So let's simplify this. Obviously, when simplified, x cubed over x squared is just x. So what I get here is the limit as x tends to infinity of 4x over 5. What is this limit? As x tends to infinity, 4 times infinity on the top is infinity, and infinity divided by 5 is infinity, still infinity. So the limit we got is infinity, is not a finite number. So you should use choice B. It's a divergent sequence. Okay, let's do another example. Let an be equal to 5n, 5 times n, over e to the power of n. And n is more than or equal to 1. Which one is correct? A, the sequence converges to a finite value, or the sequence diverges. First of all, what function do you think would be appropriate for this example? F of x equals, in the general term of the sequence, replace n's by x's. So it's going to be 5x over e to the power of x. Now let's see that what is the limit of this function as x tends to infinity. The limit as x tends to infinity of 5 times x over e to the power of x. Which rule should we use for this limit? So as x tends to infinity, 5 times infinity is infinity, but at the same time, in the denominator, e to the power of infinity is infinity. So we have the situation of infinity over infinity. Which rule should we use? As you know from Calc 1, we use L'Hopital's rule. Let me put an H here. indicating that we are L'Hopital's rule. So this is the limit as x tends to infinity. The derivative of 5x is 5. I'm using L'Hopital's rule, so I differentiate the top, which is 5. The derivative of e to the x is still e to the x. Now let's try this new limit. The top is just 5, constant 5. The bottom, x tends to infinity. E to the power of infinity is infinity. So in fact, this is 5 divided by infinity. So the top is just a constant 5. The bottom is e to the power of infinity, which is infinity. And 5 divided by infinity is 0. This is similar to some of the limits that you have seen in Calc 1. So, and 0 is a finite number. So the answer is A, and the limit is 0. Let's do another example. Which one is correct? The sequence, let me write the general term, e to the power of n over n squared plus 4n plus 1. A converges to a finite number, and that finite number should be typed in this box, or it simply diverges. So to use the theorem that we related a sequence to a continuous function, which function do you consider for this example? Obviously, f of x equals, in the sequence, the general term of the sequence, replace all the n's by x's. E to the x over x squared plus 4x plus 1. Now we find the limit of this function as x tends to infinity, e to the x over x squared plus 4x plus 1. As x tends to infinity, both the top and the bottom tend to infinity. So I need to use L'Hopital. The derivative of e to the x is e to the x. The derivative of x squared plus 4x plus 1 is 2x plus 4. Now when x tends to infinity, e to the infinity on the top is infinity, and at the bottom, 2 times infinity plus 4 is still infinity. So we can keep using L'Hopital's rule. The derivative of e to the x is e to the x. The derivative of 2x plus 4 is 2. Here we cannot use L'Hopital anymore because there is here no ambiguity. When x tends to infinity, the top is e to the power of infinity, which is infinity, and the bottom is just 2. And infinity divided by 2 is infinity. No L'Hopital anymore. So this tend to infinity, meaning that it is a divergent sequence. Okay, let's do another example. The sequence ln of n over n to the power of 5. A converges to a finite number or diverges. So which one is correct? So the continuous function we consider is ln of replace n by x, ln of x over x to the 5. So I need to look at the limit as x tends to infinity of ln of x over x to the 5. What is this limit? As x tends to infinity, ln of infinity is infinity on the top. At the bottom, infinity to the power of 5 is also infinity. So we can use L'Hopital's rule. What is the derivative of ln of x is 1 over x. What is the derivative of x to the 5? 5x to the 4. So let's simplify this. 1 over x divided by 5x to the 4 is 1 over 5x to the 5. Using basic algebra, we can simplify like this. There is no need to L'Hopital because here, for this step, we don't need to use the L'Hopital because when x tends to infinity, the top is a constant 1, the bottom is 5 times infinity to the power of 5, which is infinity at the bottom. So and 1 divided by infinity is going to be equal to 0. So this is a convergent series, I'm sorry, sequence, and it converges to 0. So this sequence is a convergent sequence converging to 0.